Based on this potentiometer value, I am choosing which LED to blink. I can use this potentiometer for changing the menu in the LCD monitor. Also, I can use this potentiometer for controlling the speed of a DC motor. I can use this potentiometer for controlling the brightness of an LED, especially working with any kind of analog sensor. You need to know how to deal with this analog input. In this video, I will tell you everything step by step, and I will show you a project for this one. Please keep watching until the end. Alright, let's do the coding now. First, let's import pin and ADC. Then we need to declare the pin number 28 as an analog input. So I name it as analog, and I am declaring pin number 28 as an input. Also, I am making this input as an ADC input. Okay, so I'm done declaring the pin 28 as an ADC input. Then let's just try to read this one. So in this while loop, we can read the value from the analog pin using this function read U16. So this read U16 will return us the analog value here, and now let's just print this value. I am also making a delay of 1 second. The coding is done. Let's check it. If you love this video, please give me a thumbs up. That will inspire me to make new videos, and don't forget to subscribe my channel. Okay, so I connected the Raspberry Pi Pico board to my computer, and let's just confirm it. So it is connected to pin number 9, and if everything got connected correctly, then you will see the file system here. So now let's try to turn this on. So I run the code, and you see this is reading the analog value from this one, and if I now rotate this, the value is increasing. You see in the console window, and it will go maximum of 65535. So this is the maximum value for this analog input, and if I decrease this one, it will go almost 0. So you see the lowest value we can read is like 192. Theoretically that should be 0, but this analog input pin has some offset, so we are reading this 192. For now we are not doing anything with this one. Let's just keep doing the code. Right now I will add some more code to use this value for the blinking LED. So we will try to use this analog input value as an output value for the PWM, so that we can control the brightness of this LED. Let's do the coding. Okay, so for changing the brightness of the LED using the ADC value, we need to import this PWM, and we also need to declare a pin. So I can declare the LED to the pin number 0 as an output, because it will be a digital output. Also I need to make it as a PWM pin, because we will try to change the brightness based on the analog input pin. So as we are using the PWM, we need to set the frequency. So if you don't know how to use this one, you can see my previous video on this one. So I am setting the frequency as 4000, and this is, so now I just need to set this value to this LED duty cycle. So I will use duty underscore U16, and I will pass this value to this one. So now the ADC is reading the value that is stored in this value variable. Then this value variable is passed to this LED duty cycle. So this is pretty simple, and let's see what's happened in the hardware. In the hardware part, I connected the LED to this GPU pin 0, and now let's run this code by hitting this run button. So I'm now running this one, and you see the LED is like too dim, so let's just increase the brightness. So you can see in the serial console the value of ADC is increasing, as well as this is increasing the duty cycle value. So gradually the LED will be more brighter and brighter. I think you can see this one. it's increasing, and I am now increasing it to its maximum value. Okay, so the analog is now to its maximum value, as well as the brightness of the LED. If I try to decrease it again, you see the brightness is decreasing, as well as the analog input value is decreasing. So this is pretty simple to use in your code. You can use this code with any sorts of analog input sensors, potentiometer, buzzer, motor driver, or anything else you have that has some analog output. Thank you.